The chapter is triangles for standard 10, and this is part 5. So in previous part we were doing problems related to similarity, criterion for similarity. So we learned AA similarity, then SSS, SAS and RHS. So we will be continuing with some more problems related to that. Now here the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by OD. You have to show ABCD is a trapezium. So we have earlier done in part 2, I think it was given ABCD is a trapezium and you have to show this, prove this. So here now it is a converse, the ratio is given, now you have to prove ABCD is a trapezium. So to show ABCD is a trapezium, it's enough if we are able to prove AB is parallel to CD, because in any quadrilateral, if one pair of opposite sides are parallel, then you can say it is a trapezium. So our now aim should be to prove AB is parallel to CD. So we can prove this using BPT or using the criteria. So we will prove in both ways. So now we will first prove using BPT. So let OE is parallel to AB. So we can write OE is parallel to, we are drawing OE parallel to AB. So AE by ED is equal to AO by OC. That is in triangle DAC. In triangle DAC, because we are drawing OE parallel to AB, so AD, sorry, it is in triangle ADB. In triangle ADB, OE is parallel to AB. So we got AO, AE by ED is equal to we have to do, sorry, this is also wrong. AE by ED is equal to BO by OD. AE by ED is equal to AE by ED is equal to BO by OD. That is in triangle ADB. Now it is already given AO by BO is equal to CO by OD. So we will write AO by BO is equal to CO by OD. From this we will interchange this. So we can write AO by CO is equal to BO by OD. Cross multiplying. This goes here and this comes here. So this is 1 and this is 2. From these we can say AE, you can equate this from 1 and 2, we can say AE by ED is equal to AE by ED is equal to AO by CO. We will get AE by ED is equal to AO by OC. So from this we can write, this is from 1 and 2. This is from 1 and 2. So now if we have AE by ED is equal to AO by OC, we can say OE is parallel to, therefore OE is parallel to CD. Converse of BPT. Now we have OE is parallel to AB. Now we got OE is parallel to CD. So OE is parallel to AB and OE is parallel to CD. Therefore, AB is parallel to CD. Therefore, ABCD is a trapezium. Now we will, so this is BPT that we have used. Now we will use the criterias. So now AOB, and we will consider these two triangles AOB and COD. Consider triangle AOB and triangle COD. Now AO, you can write AO by BO is already given. AO by BO is equal to CO by OD is already given. Now we have these two angles same, vertically opposite angles are equal. The angle AOB is equal to angle COD, vertically opposite angles. So now you can use the SAS criteria. So the included angle is equal and the sides are proportional. Therefore, triangle AOB is similar to triangle AOB is similar to triangle COD. SAS similarity. So we can write, from this we can write angle ABO is equal to CDO, angle CDO. This is corresponding parts of similar triangles. You now after writing this, you have to write the proper order, and after this from here only we have to write these, not seeing the figure. So ABO is equal to CDO. So ABO will be, ABO is this angle is equal to CDO. So we got these two angles are equal. Therefore, we can say AB is parallel to CD because the alternate angles are equal. Therefore, ABCD is a trapezium. So unless it is specified in the exam, you can use either of the methods. So here in the figure, AB is parallel to CD is given. We have to find the value of x, and these sides are also given in terms of x. Now we will consider the triangle, these two triangles. Now since these are parallel, we can say this angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So we can consider the triangle, these two triangles. So angle 1 is equal to angle 2 and angle 4 is equal to angle 3. The reason is for both CD is parallel to AB, alternate interior angles are equal. So we can say triangle AOB is similar to AOB. So the angle equal to 1 is 2. So we have to write COD, triangle COD. So from this we can write AO by CO is equal to OB by OD is equal to AB by CD. So what is AO? AO is x plus 5 by CO is x plus 3 is equal to OB is x minus 1 by x minus 2. So now we will solve this. So x plus 5 into x minus 2 is equal to x plus 3 into x minus 1. So this is x squared minus 2x plus 5x will become 3x minus 10 is equal to x squared minus x plus 3x is plus 2x minus 3. So x squared and x squared will get cancelled. So 3x comes here, it is x is equal to 10 minus 3 is 7. So x is equal to 7. This is AA similarity. So in triangle ABC, D is the midpoint of BC and E is the midpoint of AD. So as and when you read, please mark these things in the figure itself so that it is easy for you to proceed further, and you can do it much faster also when all the details are indicated in the figure. So now you have to prove BE is to EQ. BE is to EQ is 3:1. So this ratio is 3:1 is what you have to prove. So first for this we will draw one line DP which is parallel to AC. So construction is draw DP parallel to AC. So these two are parallel. Now consider these two triangles. Consider triangle PED and triangle AEQ. Now we will prove these two triangles are congruent. So we have these two are equal, and then we have this angle, we will write this as angle 1 and this is as angle 2, and this is 3 and this is 4. So PED, this triangle, if you say take angle 1 is equal to angle 2 vertically opposite angles, and then we have these two AE is equal to ED or PED. Now we have to write ED is equal to AE, it's already given, and then we have angle 3 is equal to angle 4. It is alternate angle because we are drawing DP parallel to AC, so 3 and 4 becomes alternate angles. Alternate interior angles because DP is parallel to AC. So therefore triangle PED is equal to, so for P, E and D you have to write Q, E and A. Triangle Q, E, A. A as a congruence. From that we can write PE is equal to QE. So this is CPCT. So this is we will write this as equation 1. Yes. So now BD by DC will be equal to BP by PQ, because PD and is parallel to AC. So we'll write this as in triangle QBC or CBQ, PD is parallel to AC. So we can write BD by DC is equal to BP by PQ. So now BD by DC we know it is 1. So 1 is equal to BP by PQ. The reason is D is the midpoint. The reason is BD is equal to CD given. So from this you get BP is equal to PQ. Now EQ is equal to PE we have. So we will write that as, now from that one we will write PE is equal to QE so EQ can be written as half PQ. Yes, EQ can be written as this is equal to half PQ. So this PQ can be half of so this we can write it as BP equal to PQ can be written as half of BQ. So this we will write it here as PQ can be written as half of half BQ. So this is equal to 1 by 4 BQ. So we got PE is equal to 1 by 4 BQ, and we know BP is equal to PE is equal to EQ. So PE is equal to EQ and PE is equal to 1 by 4 BQ, and BP is equal to PQ. BP is equal to, we'll write it in a better way. Okay, let us do this in an easier way. Yeah. Now we have BP is equal to PQ and PE is equal to EQ. So let PE is equal to X. Therefore EQ is also equal to X. Now we will write BE. PE is equal to QE. PE and QE are equal. Now BP equal to PQ. This is from 1. Now BP is equal to PQ. So PQ is equal to PE plus EQ, that is equal to 2x. So BP is equal to PQ, so that is equal to 2x. This is from 2. So now we can write, now we got BP is equal to 2x and PE is equal to x. So BE is equal to BE by EQ is equal to, BE can be written as BP plus EP by EQ. So BP is 2x, PE is x by EQ is x. So this is 3x by x, that is equal to 3 by 1. Therefore BE is to EQ is equal to 3 is to 1. See you all with more problems in my next video.